Welcome back again to Wildcat Academy. Today we will be learning about factoring trinomials in quadratic form. Quadratic form trinomial, first of all, the trinomial will have three terms, or a trinomial has three terms. In quadratic form, the exponent of the first term will be double the exponent of the middle term or the b term. Now, typically, the trinomials that we most often see would be of some form like this, where we have degree 2 and degree 1. So you can see that the first term is double the middle term. But in quadratic form, we can also factor these so long as the first term polynomial, first term of the polynomial is twice that of the middle term. So you can see 4 is twice that of 2. So you can see that again in the most general form. We have the ax, the bx, and the c, so don't concentrate on that so much as you just look at the exponents. And the first exponent is 2 times n, where the middle exponent is just n. So again, if we can, wouldn't matter how large these get, we could have x to the 10th, 4x to the 5th, plus 3, and we could still factor this using quadratic form. Whatever form we normally use to factor quadratics, we could use for factoring any trinomial in quadratic form. I have a very simple one here. Almost every method, other than guess and check or trial and error, revolves around the idea of taking a times c and then finding the factors that give us b, whether we're splitting the middle term or the x method. I know there's a slip and slide and a bottoms up. There's several different methods to factoring trinomials. I use the x method as far as an algorithm goes. As you become a stronger mathematician, I do encourage you to, and you learn more about factoring, to work on your guess and check strategy or trial and error strategy, where you're just seeing the factors of the polynomial and being able to predict those based on the patterns of the third term and the middle term. So, whatever method you use, it will not matter. Like I said, I'm going to take the product of a times c here, and I'm going to put it up in this is just to organize my thoughts. That's what the x method does, is just an organization. Any method you study is going to work the same way. So we're going to take the value of a, we're going to multiply it times c, which is 12. We're going to put b down here, and then we're going to ask ourselves what multiplies to be a times c but adds to be the b value. So the answer to that question is 6 and 2, because 6 times 2 is 12, and then 6 plus 2 is 8. And then we will divide by the value of a. And the value of a in this case is 1. So then this bottom number will give you the coefficient of x in your binomial factor, and the top number is the constant that is added to it. So we have 1x plus 6 and x plus 2. Now, so that's a traditional quadratic trinomial. This one is a quartic trinomial. You can see it is a quadratic form. Again, we're going to recognize that because the leading exponent term has degree 4, and the middle exponent is degree 2. So that first one is twice the middle term. So we're going to organize our thoughts over here. We will take a times c, which is 1 times 4, and put 4 up here, put a negative 5 down here, and ask ourselves, what multiplies to be positive 4 and adds to be negative 5? So we know it has to be negative numbers, so we're going to use negative 4 and 1. The other option would be 2 and 2, but that does not add to be negative 5. We'll put them both over 1. We simplify those fractions, and then we can write out our x squared minus 4 and x squared minus 1. Now, when we have a quadratic trinomial, we don't have to worry about there being another factoring step unless we forgot to factor out a GCF. But when we have a quartic or degree 6, we might have to use some of our other factoring methods for binomials, which is difference of squares, difference of cubes, sum of cubes. So when looking at this now, we can see that these two terms, x squared minus 4 and x squared minus 1, are both difference of squares. If you aren't familiar with how to factor difference of squares, check out the video. There should be a link right up here that will help you factor difference of squares. So we will take the square root of our first term, which gives us x, and then the square root of 4 is 2 and 2, and 1 will be plus, 1 is minus. So when we're factoring difference of squares, we end up with conjugates. You can see that that is the case here. So we'll factor the square root of x squared, which is x, and the square root of 1, which is 1 and 1. 1 will be plus, and 1 will be minus. And you end up with 4 terms from this quartic trinomial. That doesn't always happen. Sometimes it does, sometimes it doesn't, but it is something we always have to check when we end up with quadratic binomials as factors of the trinomial. And that will always occur whenever we have a degree 4 trinomial. We will end up with 2 quadratic binomials. So we have to check that. Alright, so example 3. So we're going to organize our thoughts here one more time. We're going to take a times c, negative 12. And we're going to put positive 11 down here at the bottom, and we're going to ask ourselves what multiplies to be negative 12 and then adds to be positive 11. Well, we want a large number, so we're going to use 12 and then minus 1. You can see that that multiplies to be the negative 12 and adds to be 11. So we'll put them both over 4, and then this side simplifies to 3 over 1. And I would encourage you to continue to do that guess and check. As you're moving into higher level mathematics, it's going to be important. So, the way you do that is just thinking about what multiplies to be 4 and what multiplies to be 3, and then trying to work it around until you get that middle term. But we've already done the heavy lifting here on this problem, so we get 1x squared plus 3 as our first factor, and then we get 4x squared minus 1 as our second factor. A little smudge there. So 4x squared minus 1. And again, we're going to check for difference of squares. We have a plus sign, so we know that we don't have difference of squares here. There is no sum of squares factoring problem, so we are done on this binomial. However, on this binomial, we can see we have a perfect square of 4 and a perfect square of 1, so this one will factor again. So we will bring this factor down, and then we will factor this one using difference of squares. So the square root of 4x squared is 2x, and the square root of 1 is 1 and 1. 1 is plus, 1 is minus. And then we are finished. Once you have a linear binomial, unless you've missed a GCF early on, you will be finished with those factors. They will not factor again. Alright, so our last example, example 4. We're going to end up with some really large numbers here, which is the disadvantage of the x method. Looking at example 4, we're going to start off with making our little x over here, organizing our thoughts about a times c, which is 144. That's the 4 times the 36. And then we're going to put negative 25 down here. And then we're just going to ask ourselves what multiplies to be 144 and adds to be negative 25. This is kind of a large number, so I'm going to put this over here. You've got 1 and 144. You've got 2 and 72. You have 4 and 36. You will have 8 and 18. You'll have 16 and 9. And 48 and 3 looks like. Maybe some others there, but we can go ahead and stop because we can see 16 and 9. These will combine to be 25. They will add. We know the signs are going to be the same because this is a positive number here. So it's either going to be positive, or negative, negative. They add to be negative. It'll be minus 16 and negative 9. So sometimes even with the algorithm with the a times c and the b values, whether you're using the x method, you will end up with really large numbers, and there's several different options here that we might choose from. And identifying those, it's not going to hurt to write this out. Sometimes factoring problems, it just takes a minute to work those out. So we're going to put them both over the a value now. This fraction does not simplify. This one simplifies to negative 4 over 1. That will give us our two factors. We will get with x squared minus 4 and 4x squared minus 9. Again, we are going to check both of these. Looks like we have both sets are going to give us difference of squares. So we're going to factor this first one into x minus 2 and x plus 2. And then this binomial will factor into 2x minus 3 and 2x plus 3. So once we see that, we have 4 linear binomials when we're finished. No more quadratic binomials to work with. So we will be done. 2 more examples of degree 6. We're going to use our magic axe. We're going to speed up just a little bit here. I think we kind of have the handle on factoring the trinomial. We're going to get x cubed and x cubed. We're going to ask ourselves what multiplies to be negative 4 and adds to be positive 3. That's going to be positive 4 and minus 1. So in the case of a degree 6 trinomial that's in quadratic form, we have to look for sum of cubes and difference of cubes. So this first term that we've gotten from our first factoring step, x cubed plus 4 is not a perfect cube, but x cubed minus 1, the 1 is a perfect cube. So we can factor this binomial again using the difference of cubes. So we'll bring this down. If you haven't already done so, you can check out the video on difference of cubes and sum of cubes. So there's a link in the description below. So we will take the cube root of x cubed and the cube root of 1. We will get x and 1. Then we'll multiply x times x and get x squared. X times 1 is x. 1 times 1 is 1. Then we will use the acronym SOAP. Same as our original binomial. Be minus. Opposite in the first one in the trinomial be plus. And then this one is always positive. Looking at example 6, this trinomial will factor negative 8, positive 7. We will then use positive 8 and minus 1. That's supposed to be a positive 8 there. Divide by 8. This gives us 1 over 1, which gives us x cubed plus 1 and 8x cubed minus 1. So we have 2 problems here, 2 binomials now, that one is the sum of cubes and one is the difference of cubes. So we're going to factor this first one again, x cubed and 1. That'll give us x and 1. We can take the cube root of those 2 terms, and then x times x is x squared, x times 1 is x, 1 times 1 is 1. It'll be same, opposite, always positive. And then this binomial will factor into using difference of cubes. It will be 2x and 1. 2x times 2x is 4x squared. 2x times 1 is 2x, and then 1 times 1 is 1. And that will be same, opposite, always positive. All right, and we're all finished there with that problem. If you found the video helpful, be sure to hit the like button below. If you haven't already done so, subscribe to the channel and look out for more great videos from Wildcat Academy.